Good evening to everybody. My name is Abhinas Behra. I am working in Hindustan Aeronautics Limited, Sukhoi Engine Division. It is situated in the state of Odisha, in the district of Koraput. We are manufacturing and overhauling the AL31FE aero engines, which is required for powering our Su-30 MKI aircraft for Indian Air Force. Now we are using various type of non-destructive testing methods. As you all know, as you all aware about these various NDT methods. Now in aerospace sectors, these NDT methods practically or typically 5 NDT methods such as X-ray, liquid pendant testings, magnetic particle testings, eddy current testings, visual inspections, and eddy current testings. These 5-6 methods are very popular in aerospace NDT sector. Now, this presentation is all about penetrant testing. Now, I am what can I say? I am uploading this penetrant testing presentations for the peoples or for the freshers or for the students who seek the fundamentals, and some of the experienced people who also seek the fundamentals of this penetrant testings. Now, what is penetrant testings? You all know. Or the types of developer, types of penetrant, types of methods, indications. This is very simplest methods, and you all know about this. You all know about all these things. Now, this slide is specifically based on aerospace quality, aerospace parts, and I am going to show you something about aerospace part defects, aerospace part indications for penetrant testings. So we'll start. This is penetrant testings. Now, what are the issues to address? The issues to address are liquid penetrant, its introductions, fundamentals, techniques, and applications. Now, you just compare these two figures. Now, this is a crack. This crack is of, say, some microns levels, having some micron level width. Now, this is the, now you can see this is the crack indication. Now, this crack indications, you can see this is the apparent width of crack indications after penetrant testing. It means the width of the crack increases. You can say the apparent width of the crack increases after the application of penetrant, and this is the seeability. Now, the small discontinuities that the human eye might not be able to detect, or you cannot able to detect through your bare eyes, PT increases or enhances the seeability of these small defects. Now, you can see the width of this crack or the apparent indications that comes from the spreading of the penetrant from the defect increases the width of the crack by, say, 10 times or 20 times. It depends upon what is the type of defect and what is the nature of the crack. So this seeability term is very important. You first to remember these things. Seeability means the detection of defects, enhancement of the enhancement of the indication of the defects by the applications of penetrant testings. Now, this crack indication, you can see this is the apparent width of the crack. Apparent, I am telling you, this is an apparent width. This is not true. This is not the true width. This is the apparent width, and you can easily see the spreadability of dye not only across the crack, you can see across the surface also. Let us go to our second slide. Now, what is the meaning of dye penetrant? The dye penetrant is nothing but the combinations of dye plus penetrant. A lot of things. A lot of people simply say dye penetrant, dye penetrant, liquid penetrant, color contrast methods, ink methods. But the most simple form that you are using is known as called dye penetrant testings. Now, what is dye penetrant? Dye penetrant, when I say this word dye penetrant, it comes with two words, dye plus penetrant. Now, what is a dye and what is penetrant? Now, dye is a powder form. Dye is the powder form. Means, see, it's the coloring agent. Whenever some old man is dyeing is trying to make his hair black with dye powder or dye, some kind of you can say the black color dye. Same kind of principle applies for this dye penetrant also. Dye is the powder form. It adds the colors to the penetrant. Penetrant is the liquid carrier. Now, what this dye and penetrant and most of the hydrocarbons. Now, different manufacturer comes with different dye and different penetrant combinations. Nobody is going to tell you about the exact combinations or what are the type of dyes, the chemical formulas of dyes and the chemical formula of penetrant. But as a layman terminology, you can know this dye penetrant is a combination of dye plus penetrant. Dye is the powder form and penetrant is the liquid carrier, transformer oil and kerosene oil and some of the liquid carrier that can be used. Now, the combinations of the third point says the combination of these two things comes in a soluble or suspendable form, and finally we get the so-called dye penetrant liquid oblique ink oblique paint. Different type of terminology, different used in different countries. Now, this is dye generally consists of a powder which is added to the liquid carrier, and they come in both soluble and suspendable forms, and the dye, that's why it is called dye penetrant. This is the most fundamental thing you need to remember. Dye penetrant testings. Now, you can see these two slides. There is this defect that you cannot that you cannot see with your bare eye. It is clearly visible in this slide by the application of dye penetrant testings. Now, this component you can see here before the applications of penetrant testings is not showing any kind of defect, but here you can see the crack from this hole, originating from this hole to the end of this component. Now, this is called dye check or visible dye check, or you can say red dye check. Somebody is saying it is known as color contrast inspections. Different terminology for different standards and methods that has been followed by a particular client. In aerospace sector, suppose we are using Russian technology, it is clearly mentioning when you are using a visible dye penetrant testings, they will say SAM 15B or red dye test, capillary action test, color contrast testing, etc. When you are using this fluorescent particle testings, this Russian's terminology will come with LUM 15B, LUMA, and some trade name is also mentioned, something like Jaglo tests or Magnaflux tests, something like that. Now, this three lines is very important. PT effectively requires discontinuities that is open to the surface of the part. It means the defects which are open to surface, or cracks which are open to surface, or you can say the surface cracks can only be detected through this method. Subsurface discontinuities or surface discontinuities not open to the surface can't be detected by penetrant testing effectively. Now, these 2 points are also very important. Special cleaning of parts and good eyesight. that I mentioned in my previous slide. For the visual inspection criteria, you need to have a good eyesight and you need to pass some visual inspection standards as per different recommended practices. Now, special cleaning of part means you can say the pre-cleaning of the parts, the post-cleaning of the parts. This is very important. PT effectively requires cleaning of parts. It means you can say the parts should be properly cleaned before it enters to a penetrant testing station. So the most important step in any penetrant testing is the cleaning part, the pre-cleaning of the part. Not only pre-cleaning is important, post-cleaning is also important, because you need to have the complete removal of all the penetrant material residues from all over the surface of the part. Okay, now we'll go to the next slide. I think this slide tells you everything just everything for this introduction of the penetrant testings. What can be inspected via PT? Almost any material that has relatively smooth, non-porous surface on which discontinuities or defects are suspected. Surface breaking defects, or means the defects which are open to surface, any cracks, blowhole, porosities, inclusions which are open to surface. Now, almost any material, it means the penetrant testing doesn't depend upon the type of the material, be it magnetic, be it non-magnetic, be it electrically conductive, be it electrically non-conductive, be it thermally conductive, or be it thermally non-conductive. It doesn't depend upon its shape and size. So if you go to any magnetic particle testing sections, it requires some kind of shape and size constraint. But for PT, this concept doesn't work very much. Almost any material. And second thing is that very heavy parts that will be very difficult to means other NDT methods faces difficulties for the inspection of that parts. Penetrant testings easily do the inspections of these parts, or means you can say penetrant testings can be easily applied on these parts. Now, smooth and non-porous surface, what does this means? Smooth and non-porous surface, it means it has got some kind of smoothness required, because uneven surface and rough surfaces, they will give you excessive hazy background and signal to noise ratio will be very, very less. And non-porous means the parts which are not porous in nature, or which doesn't have any kind of porous structure, having such number of holes, or you can say number of honeycomb type of structures on this part. This is known as a smooth and non-porous surface. These two conditions need to apply for penetrant testings. Now this line is very important. Surface breaking defects. It means the defects which are open to surface, or you can say surface defects. And penetrant testings is widely used in aerospace industry for manufacturing and overall inspection, both in visible penetrant testings and fluorescent penetrant testings. The next slide. What are the types of discontinuities that can be detected by PT? All defects that are open to surface. I am telling you repeatedly, only the surface breaking defect or surface defects that can be detected by PT. Now these are some typical defects like cracks, seam lamination you will find in wool products, cold shut, hard tears, porosities, blowholes, shrinkages you will find in castings, cracks, laps, external rust you will find in forgings, and cracks, porosity, undercuts, overlap, lack of fusion, lack of penetrations you will find in welds. Now how this kind of defects will be look like in PT, and what are the some typical signature or typical appearance of these defects in PT, I will show you in my subsequent slides and in the next videos. Bye bye.